Now we move from theory to real aircraft case studies, where we will see how structural principles are applied to solve actual safety and reliability issues. This case study focuses on cracking found at the STA-873 pickle fork fitting, which is a major structural attachment between the wing and fuselage of the B787. The pickle fork is part of the primary load path that transfers wing loads into the fuselage. Because it carries significant bending and shear loads from the wing, its structural integrity is critical. During assembly, improper shimming created small gaps or uneven contact between mating surfaces. Even though these deviations were small, they disturbed the intended load path. As a result, stresses were not distributed uniformly. Over time, these local stress concentrations reduced fatigue life, and cracks developed in the fitting. Since this is a primary structural joint, the FAA required repetitive inspections to ensure continued structural safety. This case study teaches important lessons about structural arrangement. The way two major structures connect determines how forces flow. If the geometry is not correct, loads will not distribute as originally designed. Improper shimming may look minor, but it can shift loads to smaller areas, increasing local stress levels. Shims are not just gap fillers. They ensure proper surface contact and correct load transfer. Incorrect shimming changes structural behavior. Cracks usually start where stress is highest. Poor fit-up increases local stresses and reduces fatigue life. Even though aircraft structures are redundant, local joints must still meet design intent. A weak attachment can still initiate fatigue damage.